All right, good morning, good afternoon, and good evening to all of those that are attending here, and welcome to our fourth installment of our beverage series webinar. So with that, again, welcome to the fourth series here, and thank you all for joining. I hope you all were able to join the other three sessions that we've had in this series. If not, the recordings are available on our website of evoqua.com. Today, we will be focusing on chemical disinfection practices and sharing our practical insights on effective disinfection with on-site electrochlorination and chlorine dioxide applications. I am joined here by my colleague, Shailesh Power, and today we'll be really talking through just, a focus around how chlorine can and has been so impactful in various applications in beverage facilities. We will then close with an insightful panel discussion, followed by question and answers with some of our chlorination and beverage experts. So this is a reminder just to post any questions at any time during this presentation. We will be able to get to them during that question and answer session at the end of the webinar. Today's session is recorded, so it will be available to you and your colleagues at a later date. So a great place really to start here, right, is again with the fundamentals. Why do we need to disinfect in a beverage facility? Well, as those in the beverage industry know, water quality and compliance are key. Waterborne microorganisms are responsible for adverse effects that can cause production downtime, negatively impact the products, and worse, can be a health risk to the consumer. The chlorination-based disinfection is effective with very low residual levels and provides strong treatment solutions with an impressive safety record. Inline validations are simplified and easier to achieve by the known performance, which in turn results in operating confidence. Chlorine-based disinfection methods have been used for well over 100 years successfully in many applications outside of the beverage industry and in the beverage industry specifically. The residual nature of chlorine adds value that other methods simply cannot provide, and for that reason, can be a perfect solution for the beverage facility and may even be in use today in your facility. With that being said, we want to go here to our first poll and better understand, which chemicals are you currently using or that are being used in facilities for disinfection in your processes. So I'll go ahead here and launch the first poll for us all. All right, so if you could all go ahead and answer the poll up here. So again, with the different options that are involved, and you can go ahead and select more than one option available as it's relevant to you and the practices that you see in industry. And so we're having a nice distribution here of answers. So still a few more coming in, so we'll give it a few more seconds. All right, I'm gonna go ahead and close the poll here and share with you all the results that we got. So, pretty good spread across the different chemical-based applications. So certainly some interesting there, and good amount of chlorine dioxide and sodium hypochlorite, which is great, because that's where we'll be focusing around the presentation today. So I appreciate you all answering that poll. So then moving on, so again, as I'm sure all of you know, or hopefully learned over this 4-part webinar series, to overcome the challenges in a beverage processing plant, high quality and reliable disinfection systems that make the user's processes repeatable are so important to their and your success. When it comes to health and safety of consumers, facilities in the beverage industry know that they cannot have a value outside of their regulatory ranges, as these hits jeopardize their product and pose a risk to their customers, which are ultimately the consumers of their products. New and more strict regulations are driving an increased ownership in the final safety and quality step before bottling. When reliability from equipment is limited, quick and easy maintenance for that facility can simply just not be possible, and this can quickly drive up costs and create more risk for that facility. Today, there is a constant pressure in facilities, especially publicly traded companies, to maximize their profits. And this means preventing any downtime to maximize their uptime. So with this in mind, the challenges here is really, how can you and other facilities maintain a validated process and document the efficacy without compromising the time of the operators? On top of that, we need to be able to help convey and demonstrate, what is that balance with that ability to disinfect with the cost to operate. And that can be established with a disinfection process that ultimately leads to less downtime and thus more uptime to produce product, thereby increasing line utilization optimization, labor, and material costs. For these facilities, ultimately, right, what it's going to come down to is a desire to focus on production of their product only and to not have to handle or solve the disinfection sanitization needs. So as you could guess, disinfection can be a solution to a lot of these challenges. At Evoqua, disinfection technologies include ozone systems, UV, OSEC, analyzers and controllers, gas feed systems, and chlorine dioxide generation equipment. And again, today we're focusing on the exciting topic of chlorine-based disinfection via OSEC and chlorine dioxide. For each beverage facility, these diagrams will certainly differ, but this process map here is to give a nice simple overview of where the disinfected water can be used within the process. If chloramines are present, different processes are used, and care should always be given to that type of design. Again, this is a nice view to really start to help you think and understand, where are the different applications in, and as asked in that previous poll, right, you may be using one chemical in one location and a different type of chemical or different type of disinfection altogether in a different area of the facility. Because again, this may differ a fair amount from plant to plant, but the concept really is there in terms of where the different methods of disinfection can be used. Specifically for our focus today, chlorine-based solutions can be used in many ways in the beverage industry for disinfection against microorganisms. The key ones we will work through here is clean in place, also known as CIP, surface disinfection and sanitization, and cooling water applications. So as mentioned on the previous slide, right, these are really the three applications where we see chlorination successfully used today in the beverage industry. When it comes to clean in place, chlorination methods have been used in these CIP applications for a long time, leveraging the residual nature of chlorine to provide disinfection during the entire shutdown period. This method is most successful in applications where the process can be then heated after the disinfection to 150 to 200 degree Fahrenheit. This allows the chlorine residual to be heated off and thus not having an impact to the taste of the product, but still offering a clean process and unadulterated product. This type of application can be very successful in soda and juice processing facilities, given the heat of the production process. Chlorine provides a residual that continues to disinfect even after its initial application, and this can be really ideal for surface sanitization to allow them to reduce the time frame of when mold or bacteria can even start to grow. This is key in facilities where you may have longer shutdown periods or even longer lines, as it can provide a more sustainable solution for reducing the application points and the overall water consumption of the facility. It is also ideal in cooling water applications. So chlorination disinfection effectively removes biofilms from water networks and prevents their formation when continuously dosed. Chlorine is not only effective at killing the biofilm, but is also seen in some studies to have shown great success of chlorine-based treatment in detaching the biofilms, promoting the significance of disinfection in an environment where biofilm is a hazard to the overall process. So again, this will be applicable to any of the cooling applications that may be throughout a beverage facility. So here, if we start to look at kind of a simple overview of our chemistry, right? So the high level view, right, of this is the reaction between chlorine and water is forming the hypochlorous acid, or HOCl, and the hypochlorite ion, OCl minus. The hypochlorous acid reacts with any oxidizable material in the water until there is no more hypochlorous acid left to react, or until there is no more oxidizable material. So without really going too in depth into the chemistry, simply put, as I'm sure a majority of you know, as you know, chlorine is so prevalent, the active chlorine species in this process kill the microorganisms by destroying the cell enzymes and their membranes. And this is one of the great benefits of the chlorine disinfection. Its results are really well known across many industries, and I'm sure a lot of you know, the benefits of it and probably have actually seen it in action. What is important to know from the chemistry side of this, though, is that you will need to consider the concentration, the contact time, the target organisms for disinfection within your process. And essentially understanding this water chemistry is key. And a monitored and controlled free chlorine residual will provide the best microbiological disinfection for your processes. Optimal disinfection can occur when the water composition chemistry is considered. Nitrogen, ammonia, and the presence of inorganics will all impact the disinfection reaction. The best way to interpret this is with the breakpoint curve shown here. Now, it is important to build an understanding of this relationship between the contact time and the residual when evaluating the total chlorine levels. With this knowledge, you can properly size your disinfection needs, and a simple way to look at this is through the sizing equation shown here down at the bottom. This can best be regulated with a chlorine analyzer and controller like the Depalox units offered by Evoqua. And again, the purpose of this slide is not to really, again, go into the details of the chemistry and point out, what someone needs to know with this. Again, it's to highlight, that there is a lot of research and a lot of testing done over, again, those 100+ years of use of chlorination for disinfection, where people really understand it. And again, those that have been using it or are currently using it in their facilities really understand how well chlorine can be applied and how to effectively apply it. As mentioned before, regardless of the method of chlorination, proper dosage and control are critical. When applied correctly, chlorination-based disinfection can be very simple, safe, and effective. These are some of the best practices we have seen out there from the FDA, TWVO, ISBT, and others that really help set the parameters. Or I should note, right, with different processes and designs and facilities, these results really may vary, as specific disinfection rates truly do depend on the dose, concentration, contact time, pH, water temperature, etc., as mentioned before. But with the key applications we see in the beverage facilities, the required dosage rate of disinfection are really low levels of ppm, ranging from about 0.4 to 50 ppm based off of the application. This is really important to note, as good disinfection practices outlined again by major regulatory bodies and organizations like the ISBT highlight that the limits of chlorination under 200 ppm do not require any additional rinse level from a safety perspective. So again, this can be a nice advantage when using chlorine-based solutions. At the heart of our on-site technology, you can see here some of the differences between, right? So we have our on-site technology through our OSEC and our on-site technology through our chlorine dioxide generation. At the heart of the on-site hypochlorite generation system is our electrolyzer. The OSEC units have an industry-leading efficiencies to produce stable sodium hypochlorite with just salt, water, and electricity, minimizing the risk of chemical handling. As can be seen here, the chemical equation is very simple. With minimal raw material, sodium hypochlorite can be generated at a low concentration, making safer and more reliable and more efficient disinfectant. Chlorine dioxide can be formed in a few different methods and will vary from manufacturer to manufacturer of chlorine dioxide equipment. The method we feel is best suited for the beverage industry mixes sodium chlorite and hypochloric acid with a theoretical efficiency of about 80% related to the sodium chlorite input, and with about 95% conversion of the mixing. So this is really ideal for direct dosing or batch processes and leverages the dilute chemicals for small and medium scale applications. The systems that we see have great success leverage about a 7.5% sodium chlorite concentration with a 9% hypochloric acid concentration, which is really perfect for these small scale applications in the beverage industry. On-site electric chlorination systems are chosen to deliver safety, efficiency, sustainability, and peace of mind. OSEC's disinfection method is effective and proven with just the use of salt, water, and electricity, making it the safest chemical disinfection process without handling chemicals. We like to consider it chemical-free chemical disinfection for that reason. OSEC units are engineered to increase safety and minimize unnecessary maintenance and service shutdowns. The goal of all OSEC installations is to ensure that everyone goes home every day safe and that we can eliminate any worries from your operation. On-site electric chlorination has been providing these safe solutions into various markets globally for many years with a clear focus around safety. We know when it comes to your operation, you really do strive to be as efficient as possible to reduce costs and increase performance. The OSEC units will help in this effort and drive operational success at a high performing level, providing the optimal disinfection with minimal effort. The process is efficient in delivering the product you need when you need it, and the process is lower cost than bulk sodium hypochlorite deliveries, saving operational expenses and reducing risk planning costs and expenses that occur with other treatment methods when you are delivering the bulk chemicals on site. This type of technology is very sustainable, as you have the power to generate the product at a stable concentration when desired, which can eliminate the challenges, uncertainties, and risks with bulk hypodecomposition. It also can allow you to be more independent in your operations, giving you the ability to access innovative water sources and be more readily available to the raw materials necessary for this. So salt is easier to ship and easier to store for long periods. Fewer shipments required for salt and bulk chemicals, reducing the carbon footprint. With this, you can really start to gain operational independence with this type of sustainable solution. OSEC units also add the value of being user-friendly. Evoqua recognizes the importance of the ease of operation and, when necessary, maintenance. Therefore, these designs provide engineered solutions to simplify the user experience while elevating the levels of safety, reliability, and efficiency. So you can have a seamless operation and assurance of your water disinfection needs are being met throughout the entirety of your process. So with this, we'll move over to poll number 2. And I'll share this poll over here with you all. So please identify which areas of the beverage production have utilized sodium hypochlorite or have experience of using sodium hypochlorite in the applications, either in your facility or in facilities that you've used. Again, you can select multiple options here. All right, so still seeing a few more answers coming in. All right, so I'll go ahead and close the poll here and share the results here. So it looks like we see it a lot in incoming water utility and CIP. So some pretty interesting results there. So I appreciate you all taking the time to answer those. So with chlorine-based disinfection methods like OSEC, you can start to provide a sustainable solution to reduce water consumption. Given the properties of chlorine, we have seen customers be able to reduce their water consumption by going to a 3-stage CIP instead of a traditional 5-stage approach. When using this 3-stage approach, you are able to reduce your annual water usage by 25% compared to a 5-stage sanitization approach, or about 30% compared to hot water sanitization. So with this, again, this may not be applicable to all facilities, but it's starting to show some of the innovation that facilities are taking with more traditional methods like chlorination. When it comes to on-site generation of sodium hypochlorite, the efficiency and reliability of this product can also be seen in the difference in the operational costs. On average, on-site can save about 40% of the disinfection material costs compared to bulk hypo deliveries. This does not even include any additional shipping or transport fees that often arise with bulk hypo deliveries, especially in all these uncertain times that we're all living through right now. The payback period for a technology like this, like our OSEC systems, typically is about 2 to 5 years, and as it allows us to really see the success So this is really a great time to learn more about how you can start saving money for your operational costs. Now I would like to hand over to my esteemed colleague Shailesh as he takes a step back and compares the different chemical methods for disinfection and then provides more insights on the chlorine dioxide disinfection methods.
So thank you, Ryan, for that comprehensive explanation on the disinfection technology, specifically on-site generation. So before going into the details of chlorine dioxide technology, I would like to touch base with the critical selection criteria of all the disinfection chemical technologies here with. So when it comes from the economical or commercial point of view, obviously, the initial equipment cost and the operating expenses required over the period of the product life cycle is the first one. Since these equipments are dealing with chemicals, the safety concern regarding the operation and maintenance people of the plant is another critical criteria to consider with. The source of water and the water constituents against the required quality of output of water is the one which decides which chemical is the right choice for the disinfection. So this particular table on the screen is prepared keeping in mind the beverage application and hence the capacities selected accordingly. Actual relationship may vary based on the condition and system requirements. So with this, I would like to take our further poll on that, looking at where we all want to. So let me know. So please identify which areas of beverage production have you utilized chlorine dioxide. And again, you have a multiple choice here. So please select as applicable to you. I can see good inputs here, probably a couple of more minutes. Yeah. And you can see as we were anticipated that it's mainly on the incoming water, and then for the utility water, there is interesting to see that it is in the CIP for the chlorine dioxide, which is really in line with what is our expectation was. So thank you for participating in this poll, and then we further see the next slide, please. So as we know that chlorine dioxide is applied for the industrial and municipal applications for over last 60 years. As Evoqua, for the particular capacity requirement, the chemicals that been used are of very low concentration. So an example that the sodium chloride is of 7.5% and hydrochloric acid with only 9% concentration here. And again, these two chemicals are brought into a robust chemical or reactor chamber under very precise control, firstly by the metering pumps, followed by the volumetric flow meters. So the precursors and the flow or the process water flow is continuously monitored and displayed during the time of generation, which gives you more on the safety aspect. As we know that chlorine dioxide is 2.75 times effective than the elemental chlorine. So obviously, the dosage requirement is much lesser than compared to any other chemical dosage. It is to be noted here that the chlorine dioxide is highly stable across a wide range of pH. That means we can have a pH of 2 to 10 here, and that gives a good stability of dosage. For Evoqua, I would like to assure here that each component that is coming into onto the skid is selected from the material construction point of view, or the MOC of these components are chemical resistance to which they get exposed. Another advantage of the proven technology that the operator has multiple choice on the control itself. So one can have a digital control with on and off operation. On the other side, you can have analytical control with either by flow proportional method or by residual feedback or in compound. So that flexibility of operation is also very useful in certain applications. The Evoqua generation of the chlorine dioxide skid comes completely pre-piped, pre-wired, assembled, tested in the factory. That means your time required for the installation on site is very, very minimal. The beauty of the equipment is that you do not need to have special tools or tackles for any operation or maintenance. And as you can see, that all the components are available for operation and maintenance from the front of it. So the PLC-based panel, which is again robust Siemens PLC based panel, is good to communicate with any type of building management systems or SCADA. Going into further, I would like to present our first case on which the equipments are already been installed. So as you know, food and beverage industries need a considerable amount of water in the cooling side, which is mainly due to pasteurization and process cooling. And the challenge for the cooling towers are the control of bacterial slime and algae. So irrespective whether it is a recirculating type of or it is a single pass, the basic challenges for cooling towers remains the same. So why chlorine dioxide, or the choice of chlorine dioxide is not because only that what it reacts with, but also because due to what it does not react with. So for example, chlorine dioxide does not react with nitrogen, ammonia, or mostly organic contamination. It also does not react with the other chemical treatments which are equally essential for the cooling tower treatment, such as corrosion inhibitor or antiscalants. So consequently, it is found that the dosage of those chemicals remains fairly constant when using chlorine dioxide. So in this particular application, the customer had a challenge of Legionella outbreak and control on demand requirement of the cooling circuit. When installed with Evoqua's generation system, along with the analyzer and controller, it is found that they could stabilize the complete circuit in just a couple of hours. And that is running for now a number of years from the time of installation. Our second case is on the completely different application than the previous one. So here, it's a large brewery application wherein chlorine dioxide is used for rinsing and cleaning of the bottles. Since this is a large facility, it had a requirement of multiple dosing points. And with the option that is available with Evoqua's generation system of the product batch tank, we could manifold together the dosing system. And again, it was coupled with our precise analyzer and controllers, which has given a customer flexibility to dose individual product line with a very precise dose. I would like to highlight here that the produced chlorine dioxide solution from our equipment is being regularly tested in customers' in-house laboratory, and the result shows that it is a very reliable operation. So we have a satisfied, reliable customer in it with the installation of that. So with this, I thank you for your time for getting into it. And then the next one is to open for the panel discussion. So firstly, I would like my colleague Ryan to come back on the screen. And then I also introduced my colleague here, Gerhard Meissner, who is our senior manager based in Günzburg, our manufacturing facility. Gerhard has extensive experience, knowledge on all types of disinfection. So thank you, Gerhard, for joining this panel. I also welcome on the panel our second panelist is Sueli Roel. So Sueli is our industrial sales manager and rich experience specifically in food and beverage application. So welcome, Sueli, on this panel. And with this, I would like to take the first point on the discussion here, which is how does this chemical disinfection mitigate the risk of Legionella outbreak? So is it okay, Gerhard, to start with?
Yes, that's fine. Thanks a lot for posing the question to me. And yeah, it's a pleasure to be on this call. Sorry for not being able to share my camera with you. That is currently not in operation. That is not working properly. Sorry for that. Yeah, special thanks to Ryan and Shailesh for their interesting presentations. Please allow me to reply to the question, how does chemical disinfection mitigate the risk of Legionella outbreaks? Yeah, Legionella, it needs to be aware that Legionella are contained in fresh water almost everywhere, and they are spreading quickly in the plant pipework with respect to the doubling time at 45 degrees Celsius, which is just 3 hours. And this especially applies for dead water ends where they are spreading and living in the biofilms. Legionella do not survive temperatures above 55 degrees Celsius. However, usually permanently heating up the water is not an option. On the other hand, yes, spot disinfection methods like UV disinfection is insufficient because Legionella's biosphere is the biofilm inside the pipework, which means spot disinfection will not have an impact for the downstream biofilm in the pipework. Therefore, a disinfection approach, a sustainable disinfection approach, providing a deposit effect is essential, and this can only be provided, according to our experience, by chemical disinfection with a strong effect towards the biofilm, which is on the one hand removed and on the other hand avoided to reform. Especially such effect applies for the use of chlorine dioxide disinfection because of the specific dissolved gas character of chlorine dioxide. Yeah, if you like, I may. Yeah.
Thank you, Gerhard. And Sueli, would you like to add something to that?
Oh, very short, because the answer from Gerhard was so complete that thanks first for the presentation, which was very clear. Also, Ryan. The only thing I would like to add is any disinfection should work complementary with the filtration. The particulate could generate some incrustations as well. So any disinfection will be more efficient if you add filtration to remove these particulates that can be first aging in the pipeline, second activating as nutrition for eventually surviving microorganisms, and last also to remove the particles from the circuit. That's the only thing I have to complement.
Thank you, Sueli. Thank you both, actually. And I think the next point on the panel discussion here is what's the impact of chemical disinfection methods on sustainability targets for the industry? So again, I would come back to you, Gerd, on it, please.
Yeah, I will be pleased to reply. So on the one hand, sustainability may be related to equipment durability as well as process stability, but also to the carbon and water footprint. In this context, we wish to emphasize that Evoqua provides proven and highly durable equipment, which is sustainable. And on the other hand, Evoqua's disinfection technologies enable water reuse, for example, CIP water reuse due to the deposit effect of the applied chemical. Furthermore, our OSEC, our electrolyzer technologies, avoid water on the road, which is, for example, chiefly contained if you purchase commercial sodium hypochlorite. The majority is water that is being conveyed to the facility. And this is, of course, being avoided if you generate a disinfectant on site. An additional effect that is worth mentioning in this context is that there is also the decay of commercial hypo that needs to be considered, which means that 20% of the chlorine decays within a month roundabout. And this is a striking advantage also of our OSEC technologies, because we produce just a solution that is required for the immediate consumption.
Exactly.
And you have to consider that if your operation is running smoothly, if you have your chemical approach with this residual, you are contributing to avoid the contamination. For example, in the cooling tower that you mentioned, you can avoid zebra mussels, biofilm, algae. All these can block the system or can generate a film. For example, in the platelet exchanger, this will reduce the transfer efficiency between the both sides of the system, because you have this lay in between. And so a chemical disinfection with this residual capability assures that your operation will be smoothly, and this is contributing to saving energy and reducing your water footprint.
Thank you, Sueli and Gerd on these things. And I could see there are a couple of questions coming into from the audience. So may I request Ryan to take over and kick off on those questions, please?
Yeah, absolutely. Yeah, so there's definitely some interesting questions coming in, and remind you all, feel free to continue to post more questions into the question part here. But we'll jump off with one that I think is very relevant to the environment we're all living through right now. Of given the challenges and disruptions in the global chemical supply chain, how can on-site generation and solutions from Evoqua address these challenges? So Sueli, if you don't mind answering that question, that'd be great.
Good. So one of the most interesting advantages of our OSEC or electrolyzer is that you just need salt, because water and energy you have on your plant. However, energy can be more expensive now, but you just need to store salt, and this is very simple. You don't need special areas, you don't need special containers, and you have your disinfectant produced on time according to your needs in the factory.
Yeah, that was great, Suela. Thank you. So another question coming in that I think is pretty interesting. I'm going to summarize it a little bit here, but it sounds like someone was having some issue with ironing fouling on their downstream UV system. So one of the questions they want to have, and I'll pose this over to you, Gerhard, is there a way to apply chlorine dioxide on the main incoming water tank, but also prevent corrosion downstream?
When you add chlorine dioxide, you need to be aware of two things. The one thing is the excess of acid that is in the chlorine dioxide solution. The other thing is that chlorine dioxide also oxidizes iron. So iron 2 and iron 3 is getting oxidized by chlorine dioxide, which then precipitates to iron hydroxide. And for iron hydroxide, you would need some settling tank or something to get it out of the system, because otherwise it will be a nice area for germ growth, and also for coating and disturbing other processes. So getting rid of these iron hydroxide is quite relevant in this context.
Yeah, that's a great explanation. Thank you, Gerhard, for that. So we've got a few questions here. I'm going to try to pull it together into kind of one and pose this over to you, Shailesh. So these are all really around chlorine dioxide and biofilm. So there was kind of a few questions around this of, does chlorine dioxide just break down the biofilm, or does it prevent? And do you have any experience with detachment of the biofilm when dosing chlorine in cooling towers or piping? So if Shailesh, if you could take that one.
Yeah, so basically with the use of chlorine dioxide as versus other chemical disinfection, the effectiveness is mainly seen on the biofilm. So I would say that when it's a new plant, it doesn't allow to form the biofilm itself. But in case where there are installations where it has been used by some other, and then when you introduce chlorine dioxide, it first tries and breaks all those biofilms that's been formed. So we have seen on the practical side that when the dosage starts, we actually starts on very low, because that biofilm breaking would then affect directly a choking of or the blocking of the lines. So yes, chlorine dioxide is on the very higher side on the biofilm breaking.
Yeah, that's a great explanation. And then a few other kind of questions coming in, all kind of similar. So I think with this one, be good to kind of break this up. It's really around safety and what is the advantages with on-site generation for mitigating some of these safety concerns. So I think if Garrett, if you could start with the on-site electrochlorination technology with our OSEC, and then Shailesh, if you could talk a little bit about that from the chlorine dioxide, I think that would be good to answer those.
Oh, I like to. Thank you. Yeah, OSEC technology got some striking advantages with respect to safety. So there are no dangerous precursor substances involved. So it's just water and salt that is being transferred by means of electricity to the sodium hypochlorite that you immediately need for your process. So you just produce what your process requires. So it's a minimized operator risk. Moreover, the generation of chlorine in accordance with the process demands provides the advantage that you have a smaller leakage risk, because you got only a very small intermediate containment for the sodium hypochlorite solution as compared to a large commercial hypo storage tank that would need to be fitted into a separate chemical room And so it's a striking safety benefit. And compared to chlorine, of course, we don't have the risk of chlorine leaks.
Yeah, and sorry, and just quickly on the chlorine dioxide safety concern, that we as Evoqua Wolstenchinden has introduced chlorine dioxide technology way back in 1939, but from then to now, the change on the design and the focus is mainly on the safety of the system. So as I mentioned, that all those components and the process that's been involved in generating of chlorine dioxide is built around the safety concept of it. And the chemicals, again, which we are using are dilute in nature and mostly available in all the part of the world. So logistic wise, we also trying to get into how to mitigate the risk of the chemicals as well. So thank you very much for that.
Yeah, thank you both for those explanations. I think those were good. So I see, yeah, we're just over on time, the time we allocated here. So I do apologize for anyone whose question we were not able to answer here, but you know, we certainly will be able to follow up. There will be a question or a poll that will come out to you guys after this webinar. So if you do want us to follow up with any of your questions, please do you know, indicate so on that. With that as well, you hear is the contact information from the team here today, and then also, you know, feel free to reach out obviously to Evoqua.com, and there's plenty of great employees within our organization that'd be happy to answer more questions around this. So again, you know, I do really want to thank you all for the time that you had with us, and for those that attended the whole series. Certainly appreciate you sticking with us through this 4-part series. So again, as mentioned, if you do have any other questions, we'll definitely make sure to get back and answer all of this. This session was recorded as well, so will be available to all of you. So if you do have colleagues or others that weren't able to attend today, they will be able to have access to this. So again, I appreciate you all taking the time, and have a good rest of the day.
Thank you.
Thank you.
Thank you.
Thank you to all of